Hey, we are talking about relative extrema. We have the function here, g of x is equal to negative 2x to the fourth plus 20x squared minus 18. And the goal here is we want to find the relative max and min, and then we're going to indicate where this function is increasing and decreasing. Well, as we can see by taking a look at the picture here, which this picture is making me hungry, we've got a relative max occurring right here at this red dot, and another relative maximum here, and then a relative minimum. Now this is something that I haven't stated earlier, but this is considered to be truly a relative minimum here, and I never have stated yet in these problems what exactly the definition of relative really means. But if we were to take some interval containing this point, take for example negative 1 and 1, and we were looking at just some open interval between negative 1 and 1, this point here on the graph would consider to be the minimum. Okay, it's the minimum. So if you were to look at some interval between for example negative half and positive a half, right, on an open interval, this is a minimum. Because clearly we can see down here, I can pick a point down here on the graph that is a much smaller y value than this point here. But relative means because it's just in a small area around this point right here. Now this up here is, we're calling it a relative max, but it's also considered to be, you can consider it to be an absolute maximum, these 2 points here, because they are the largest y values of all the y values in the set of this graph. And of course keep in mind that we're only seeing a small portion of this graph because we are on an interval between negative infinity and positive infinity. Now some textbooks consider this to be, I've been using absolute and relative. You may also see the terms global and local. So this would consider to be, for example, a global maximum, these two here, global maximums, and this would consider to be a local just being in this small area right here, a local minimum. So we can consider a relative max to also be an absolute. Okay. All right, well, first thing we're going to do is take the derivative. So let's get busy on the math. So I've taken the derivative, as you can see here. We take the derivative, we set it equal to 0, and then we solve for x. So I'm going to factor out a negative 8x, and I do that. And then what we want to do now is set both these terms equal to 0 and solve for x. Well, we set this term here equal to 0, and x is equal to 0. So that's going to be one of our critical numbers. And then the other factor, we set it equal to 0, solve for x, and we get plus or minus the square root of 5. So our critical numbers are going to be 0 and then plus or minus the square root of 5. So I've drawn this graph up here to give us a good indication of where our maximums and our minimums are going to occur and where the function's increasing and decreasing. So we place our critical numbers here. I've got negative square root of 5, 0, and positive square root of 5, which is not quite, should be lined up here with that. I don't know how that got off so much, but anyway, it's terrible. Okay, try to fix that up there a little bit. And then we've got test points here. We picked a negative 3, negative 1, 1, and 3. So we're going to take our test points, plug it into the derivative. We end up getting a positive number out. So we know that the function is increasing. Then we plugged in our second test point, negative 1. We got a negative number out, so we know it's decreasing. And then we plugged in 1, and we got a positive number out. Then we plugged in 3, and we got a negative number out. So now we know where the function's increasing, decreasing, and we can determine by maximum and minimums. So we go ahead and plug in our critical number, the negative square roots of 5. We get 32 out. And we plug in our other critical number, we get negative 18 out, and then we get 32 out and plug in square root of 5. So we have our max, our min, increase,